Hi everyone, myself CA Jagadish, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering and Technology. In this session, we are going to see about finite element method and finite element analysis. It is a technique which is used to solve the engineering problems. Take a component, the component seems to be a physical model. The physical model has a physical equations that can be solved with the help of a mathematical equations, and the mathematical equations is converted into a finite element equations. With the help of a software, the equations can be resolved, then we get the final answers, and it can be converted into mathematical equations, and again it is converted into physical answers. For this, we are using a software named as ANSYS. So before going to the FEA software and FEA technique, we have to discuss with some of the basics and origin of a FEA, where it starts. There is a concept behind the FEA is CAD, CAM and CAE. What is a CAD? Computer aided design and computer aided drafting. For what purpose it is available? It is used to draw the drawings with respect to two-dimensional as well as three-dimensional. What is two-dimensional? A diagram which represents only in x and y axis is known as two-dimensional drawings. And for a three-dimensional, the diagram represents in x, y and z axis. To draw the drawings, we have a software. For 2D drawings, we have a purely specialized software which is known as AutoCAD. This AutoCAD software which is used to draw the drawings with respect to two-dimensional. It can able to draw the three-dimensional also, but it doesn't have volume. So the AutoCAD is a software which is purely meant for 2D drawings. For other case, it is a three-dimensional drawing or three-dimensional modeling. For three-dimensional modeling, we are having a number of specialized softwares which is known as Creo, Solid Edge, SolidWorks, Inventor, CATIA and so on. From these softwares, we can able to create a 3D model. There are many modules in this softwares. First of all, starts with sketching, modeling, assembly, detailing, mechanism and so on. What is sketching? Sketching is a platform or a module which is used to create a drawing to develop the 3D model. After creating 3D model, the number of components can be assembled with the help of a assembly module. After assembly, we need assembly detailed drawing. For this purpose, we are using detailing. A component after assembly, we can able to simulate with the help of a simulation or a mechanism. So these are the modules available in 3D modeling packages. Then CAE, Computer Aided Engineering. What is it? It is a platform or a module which is used to analyze or find the solutions for loading conditions, temperature conditions, vibrational effects and many more. It is a software named ANSYS, MSc Nastron. These softwares used to analyze a component. In this software, there are many modules. They are structural analysis. In structural analysis, there are two modules or subdivisions for static analysis as well as dynamic analysis. And comes to next, it is thermal analysis. It has steady state as well as transient. Steady state deals with without dealing with the time factor, and transient deals with respect to time factor. Then computational fluid dynamics, then fatigue analysis, fracture analysis. These modules which is help to solve the engineering problems. Then next one is CAM, computer aided manufacturing. With the help of these computer aided manufacturing softwares, we can able to simulate the mechanism or machine shop structure model, and we can able to machine the components with the help of a software itself. Before going to real manufacturing, with the help of a manufacturing software, we can simulate in our system itself and whether is it doing the right manufacturing process, or we have or any errors we can able to find it out and sort out in then and there itself. Also it gives codings, that is G code and M code. With the help of a G code and M code, we will transfer it into a machine and we can able to simulate and we can produce the components in real time scenario. So these are the basic things behind FEA technique. One is CAD, second one is CAM, and third one is CAE, computer aided engineering. So with this help of these three things, we can able to solve the engineering problems. For example, a structural component, for example a beam. A beam can be fixed at one end and the load will be given at the other end. So this seems to be an structural analysis, like a cantilever beam. So by giving the loading conditions, it will react how much it can able to withstand, and it will shows how deflection goes on. Likewise, we can able to solve the temperature effects with respect to a thermal problem. Say for example, a thermal component is there, we are supplying heat at one end and we have to see the temperature distributions over the plate in the particular model. It is possible after giving a load or temperature at one end, it will gradually distribute over the plate. Then we can able to check at what point or what destination it could be the temperature effects. Likewise, we can able to proceed the component with respect to vibrational effects like modal analysis and harmonic analysis as well as transient analysis. So these are the various platforms techniques which is available in FEA. So FEA and CAE both are interrelated. So with this we can able to solve any type of problem at any conditions and any materials. So comes to FEA, there is a basic equations, that is governing equations and boundary conditions. With the help of a boundary conditions, we can able to solve the governing equation and we will produce the results. The basic formula in FEA is F equal to KU. F is a force vector, K is a element stiffness matrix, and U is a deflection. With this equation, we can able to solve structural problem, thermal problem, vibrational problem, and so on. So what is the purpose of a FEA and advantages of a FEA means? We can able to solve the problems repeatedly in short time without any loss of money. So usually there are three techniques to find out the solution for a problem. Number one, physical mode, that is in laboratory we are testing a component. For that we need time and material, so it will take it is like a tedious process. After that, theoretical calculation needs also somewhat equations, time, we have to solve it, we have to find out the exact solutions. So when comparing these two, the computational method is a very easiest one. It needs only a one-time investment. So CAE is a better option we proceed with. Thank you.